Hi, welcome back to Mr. Slover's Math. Today we're going to talk about solving systems of equations. So this is the first day of the unit. So we're going to talk about what a system is and then go from there into starting to graph them. So our warm-up is identifying the slope and the y-intercept in the following equations. So remember, the slope is the number that's attached to the x, and we saw this in the review the other day. So in letter A, my slope is -2, and then my y-intercept is the number that follows the x, which would be 2. Remember, you can write your slope as a fraction. You could have -2 over 1, or for letter B, you could have 5 over 1. It doesn't matter. For letter C, we have a horizontal line. It says y equals 1, so that means it's a horizontal line. So that means we have a slope that is 0 and a y-intercept that is 1. And then letter D, it says y equals -x. Well, that -x means my slope is -1. So you have -1 is your slope, and then -12 is your y-intercept. The second warm-up question asks you to identify the m and the b and then graph it. So once again, similar to what we did on the review the other day. So we're just identifying the slope. So the first one is 1/5, which is rise over run. I'm writing it as a fraction, and I'm reminding myself that I'm going to do two things with that. And then the y-intercept is where it crosses the y-axis and where you start. So I plot a point at -6, and I use my slope up 1. I rise 1, and then I run 5, up 1 over 5. And you guys can use your IDs to create that straight line. Similar for letter B, just different information. And then number 3 says evaluate y equals 3x plus 2 when x equals -6. So once again, we saw this on the review last week. You are just taking -6 and plugging it in where you see the x value. So y equals 3, and then I have parentheses because I'm replacing the x with a -6, and then plus 2. So this operation is 3 times -6. There's nothing there, so we're assuming that it's multiplication. 3 times -6 is -18. I add 2 to it, and I get -16. So that's all to get us ready for the next few days. We're starting systems. So what is a system of equations? Well, a system of equations is 2 or more linear equations using the same variables. We are going to focus on just 2. There are more. You could have 3 or 4 or 5 or whatever the case may be, but we are only focusing on 2. So an example would be x plus 2y equals 10 and 3x plus 5y equals 25. Two different equations, but they both have an x and a y, an x and a y. A solution of a system of equations is any ordered pair that makes all equations true. On a graph, this is the point where the lines intersect or where they cross. So once again, we are focusing on just 2 linear equations. So if I'm looking for a solution, it should make both equations true. And that's what example 1 is asking. It says determine if the following ordered pair is a solution to each system of linear equations. So I've got 2 steps here I wrote out in red. Number 1 says label your x and your y. And number 2 says plug into both equations. You don't necessarily have to label them. That's just to help us since this is the first time we're seeing this example. So x is -1, y is 5. Anywhere I see an x, I plug in -1. Anywhere I see a y, I plug in 5. So over here, I've got 5 equals negative because it says -x, so that negative is there. And then my x is -1 plus 4. Negative becomes a positive. 1 plus 4 is 5. So far, so good. But remember, to be a solution, it has to make all equations, or in this case, both equations, true. So I plug in the same x and y value, but now I plug it into the bottom equation, and I did this one in red. So 5 equals -1/5 times -1. Well, -1/5 times -1 is +1/5. 5 does not equal 1/5. That is a no. That is not true. So because both of these, this one and this one, were not true, negative 1, 5 is not a solution. It would not be where these two lines cross on a graph. Letter B, I label x is 4 and y is 1. I plug that in. So over here I have 4 plus 16 times 1 equals 20. 4 plus 16 equals 20. And then 20 does equal 20. So yay. The next one, I do the same thing. I'm using the same x value and the same y value. 2 times 4 plus 9 times 1 equals 17. So I end up with 8 plus 9 is 17. 17 equals 17. Yay. So I've got 2 check marks, 2 yays. That means that yes, this is a solution. 4, 1 is a solution to this systems of equations. If you were to graph both of these, they would intersect at 4, 1 on a graph. Letter C, you can try it your own, and there's the answer to check yourself. So this one does have you talk with someone around you and draw different ways you think two linear functions can be drawn on a graph. I don't have anything drawn here because I wanted to see what you could come up with. So take a few minutes and draw something, sketch something out. You can hit pause on this video so you can do that. And then, so welcome back. So now we got solving systems by graphing solutions. There are 3 different ways that we could have a solution or solution set to graphing a system. The first one could be one solution. So on a graph, I have 2 lines that intersect. The description is 2 lines that cross or intersect. And how to write the solution is an ordered pair where they meet. So it could be like 3, -4, 7, 10. By the way, this does not match this. I just made up this ordered pair. The second way that you could have a system of equations have a solution could be a no solution, which means I have 2 lines that don't intersect, they don't cross. So that would be my description, 2 lines that never intersect or never cross. They are parallel lines. If that ever happens, if you draw that, we would write no solution. There is no solution. There is no x and y value that will make both equations true. And then the last one is many solutions, also known as infinitely many solutions. I just shortened it to many solutions. It's a little bit quicker to write. This is 2 lines that are the same line. So if you notice, it may be kind of tough, but there's a blue line and a red line there. They are the exact same line. I would write this as many solutions. So there's 3 different ways that you could see an answer or a solution to a systems of equations. You could have one solution, an ordered pair. You could have no solution because these do not intersect, or you could have many solutions because this is the same line. Example 2 is using that information. It says use a graph to determine the solution to the system, and I want you to write where they intersect. So here I have one solution. They intersect once. There's my solution. They intersect at 5, -4. Letter B, I have one solution. They intersect once. There is my solution. Please try C and D. Check your answers. And then on the bottom one, it says draw an example for each type of solution on the graphs provided solving a system of linear equations by graphing. Notice that your drawings may not match mine. Okay, you are just practicing what one solution looks like on a graph, what no solution looks like on a graph, and what many solutions looks like on a graph. So today we introduced systems of equation. A system of equations is 2 or more lines, 2 or more equations that use the same variables. There are 3 different ways that you can get a solution. You can have one solution, you can have no solution, or you can have many solutions.